Hi, my name is Ritika and this is my team Aadarsh, Meiirbek, Siddarth and mentor Raphael, and we are presenting untargeted adversarial attacks on automatic video captioning. Let's begin with discussing our problem statement. There are many commonly used automatic speech recognition applications these days like Siri, Alexa, and these ASR are susceptible to adversarial attacks. Adversarial attacks intend to perturb input audio with noise to generate disturbed or manipulated output. Most white box attacks are easy to perform but are difficult to transfer to black box model. We'll discuss about white box and black box model in the next slide. MGAA is an effective black box attack that was successful on several image classification problems. Looking at these adversarial attacks, YouTube video captioning is an example of black box model which could potentially be harmed by adversarial attacks. For example, allowing hate speech to evade censorship. Therefore, it is important to study and understand such adversarial examples to improve the robustness of ASR system. Now, coming to adversarial attack setting, there are two major kinds of adversarial attacks, white box attack and a black box attack. In white box attack, the attacker can access the model and its parameters, whereas in a black box attack, the attacker can access only the output and it cannot access any weight or architecture of the model. Now let's jump into various adversarial attacks implemented by us. Starting with the white box attack, we have performed projected gradient descent attack. PGD attack is a constraint optimization problem which utilizes first order gradient information to find input that maximizes the loss within limit. Here in the diagram, we can see that within the limit, the input tries to go from a low loss area to a high loss area. And these are our results for PGD attack. We plotted word error rate versus the number of training iteration for different SNR. SNR is the signal to noise ratio, which is the projected limit seen in the previous diagram. We then performed a round of Graybox attack where PGD attack from one ASR model is tested on a different ASR model called transfer PGD. Our hypothesis was that the transfer PGD prediction errors should be lower than a general white box PGD model as the internal architecture of the model is different, and this is what we got. Now coming to a central idea of project, we'll discuss meta-gradient adversarial attack. MGAA has been successfully implemented in several computer vision tasks where each part of meta model is specialized in a particular task. Now we wish to apply a similar concept of MGAA to ASR models in order to generalize attack on unseen models. So MGAA is a plug-and-play method for improving cross-model transferability of gradient attacks. This architecture outperforms most of the black box attack for image data set. The idea here is to include white box ASR models into a model zoo. And from here, for each task iteration, we randomly sample set of these ASR attack white box models as a part of meta training and use one ASR model as simulated black box model for meta testing. In order to generate perturbation, an ensemble of n sample models is used in meta train. This approach focuses to generate attack examples that generalize for unseen black box model and thus are transferable. So here are our results for MGAA result. And we can see that the SNR was in the range of 30, which was better than transfer PGD. Now let's move on to our target application of YouTube video captioning, where here we see that the transcript of original audio has been perturbed by an MGA attack. The word sprog has been replaced by sprout, whereas in a PGD or a transfer PGD attack, nothing has happened. Here is a link to our YouTube video. From this, we observe that since we right now have only 3 ASR brain in our MGA attack, we expect it to perform much better with more brains. YouTube is pretty robust to adversarial attacks, but we hope to improve it further.
Now let's.
And that's it from our side. Thank you.